Hello, everybody. This is Time Niemeyer from Time Niemeyer Academy, and today we are going to prove that 1 cubed plus 2 cubed plus 3 cubed plus plus n cubed equals n times n plus 1 all divided by 2 squared. So to start off, we're going to do this by induction, so let's define our proposition. So for our proposition, let us say that P of n, our proposition of n, is that the sum of I equals 1 to n of I cubed equals n times n plus 1 over 2, all squared. Next, what we are going to do, we are going to prove the base case. So let's look at P of 1. So P of 1 shows that I equals 1 to 1, the sum of I equals 1 to 1 of I cubed equals 1 cubed. And this equals 1 times 1 plus 1 divided by 2 squared. And we know that both of these equal to 1, and therefore we have proven it. We've proven the base case. Next, let us assume that P of n is true up to some arbitrary n, which is a natural number. From this, we are now going to analyze P of n plus 1. So we've assumed that P of n is true, and now we are going to analyze P of n plus 1. So for P of n plus 1, we are going to have the sum from I equals 1 to n plus 1 of I cubed. And through the property of sums, we can split this plus 1 out, or this n plus 1, and this is just going to give us the sum from I equals 1 to n of I cubed plus n plus 1 cubed. And now, if we look at this, we are going to use P sub n to show that this is equivalent to n times n plus 1 all divided by 2 squared. And then we're going to carry this over as well. So now let's do some algebra. So we're going to square the 2, square both of these, and then we see that there's an n plus 1 here and an n plus 1 here. And we're actually going to factor that out. So now that we've factored it out, we have an n plus 1 squared all times this. And we are going to multiply the denominator and the numerator by 4 and then merge them together to show that we get n plus 1 squared times n squared plus 4n plus 4 all divided by 4. We can now factor this into n plus 1 squared and n plus 2 squared divided by 4. And if you see, we can pull that out, and we get n plus 1 squared and n plus 2 over 2 squared. And then we can factor it one more time and get n plus 1 times n plus 2 all squared over 2. And if we see, that means that our sum from I equals 1 to n plus 1 of I cubed equals n plus 1 times n plus 2 over 2 all squared. And what is this? Oh, wait. This is P k plus 1. And we have shown that this is true. We have shown that P of n plus 1 is true. And we have shown that P of n plus 1 is true only by assuming that P of n is true. So from this, we have now shown that P of n implies P of n plus 1. And we have therefore shown that P of n is true for every n in the natural numbers. And because of this, we have proved that for every natural number n, 1 cubed plus 2 cubed plus 3 cubed, all the way to n cubed equals n times n plus 1 over 2 squared. And with that, we have proved everything. And I give that a Q, E, D. Thanks for watching.